How's it going, everyone? Welcome, Eulero Gonzalez here, and today let's going to now explore about is the type section as a way to be able to describe this fundamentals of JavaScript. And you may wonder, why do I even need to do this, right? Well, the question is simple. If you want to be someone that is competent in the tool that you use, and because you want to be effective when it comes to solve any problems with JavaScript, therefore we need to understand is what are the fundamentals, the pillar of this particular tool, this language. So the TLDR of this course is to actually understand that thanks to Kyle Simpson, takes notes out of that, improve our communicational skill when it comes to talk about is the language, and therefore being able to now is when you need to explain that, do that in the most simple term possible, which means make it all of this abstract, complex, meaningful to others, and understand what is the problem that they are solving. So this is the goal of this, is understand the fundamentals of JavaScript. Kyle Simpson, which is a software developer and also the author of You Don't Know GS and Functional Light version 3, is just a way to write down his ideas based on his experience over the JavaScript development or web development. And based on his experience, all right, this is now the core structure. We can use this as a guideline to at least understand what are the fundamentals, right? And when you need to explain that, well, you already know where it comes from and you can quote the source. So this particular course is structured in this fashion when you have the types, all right? The cohesion, the philosophy of cohesion, which is now one of the pillars of this. So what is the philosophy behind the cohesion, as well as equality and stating typings, right? All of this is these three sections is one of the pillar of the JavaScript, which is the types and the philosophy around type cohesion, right? So you have types. Let me actually put it down here. No, I think that's interesting. I think you got the course overview. Okay, here we are. Exactly. This is part of the introduction, understanding the code. And also be able to, when it comes to understanding now what particular functionality or behaviors of the language has, we can take a look not only at the MDN docs, but also to the ECMAScript spec, right? And this is the three pillars that we're going to look at this, about the types. So what is the type of this value that we want to store in memory, okay? So we have now the types. We need to look at so the types, the cohesion, the philosophy behind cohesion, as well as statics typing, which is with TypeScript, and also something that we're gonna see that later. And the other is a scope, all right? So scope and functional expression, which is something that a lot of the time people like to ask this kind of question, because this is actually going to the deep root of the programmers or the computer science that knows this about what is this, and therefore they can provide now a particular solution, or they can now fix problems as they arrive. Okay, so far so good, right? Because then after we look at the scope and function expression, from functional expression, as well as the advanced scope, all right, we're also going to look now at hosting closures, part of the features of the language and the models, right? And then the other pillar, which is now the objects orientate, known as the prototype. And to know about this and the class and the prototype and the OOP versus the OLOO, right? So let's get into this. So we went through first describing what are the primitives. I am quite familiar with that. So you have now the number. So a primitive is any value that cannot be broken down. It is atomic. Okay, it is undivisible, right? Therefore, you're something that you can divide further than the atom, but in any case, at least this is our mental model. So we have now the numbers, string, boolean, big int, symbols, undefined, null, right? And we also have, and this is not primitive, we also have now is objects. And on the object you have now special type of objects known as callable objects, which is a function, and also an arrays, right? So, but the idea of this is to now dive deep into these operators here that allow to identify what is the type, what is the primitive value of this, right? So in JavaScript, variables don't have type. The value have this. We only use variables as a container, as an identifier of this value that we want to store in memory, but they don't have any values. Or variables, they don't have any types. Values do. So that's why we look now at a type operator and the several types that we can have. Primitive and objects, right? So later on, we're going to see that later about the object and stuff like that. All right. And let's get into this.
Are these values that aren't strings like null or undefined. And I see this mistake all the time in blogs. People will say type of equal undefined without any quotes. And that makes no sense whatsoever because the type of operator literally cannot return that. Guess how I know? I read the spec. It does not return an undefined value. It always returns a string. And if the string is a predictable known list,
there you got it, right? So the type of here return is always a string, and let's take a look now at this type of here. It's a type of operator from the ECMAScript. That's right. So type of. But I want to look now is at the my language spec at that particular section, so you can get yourself familiar with the identifier, parameter expression, left-hand side expressions, update expression, unity operators. You know, you're looking at the type of operator, okay, and what it does. You know, in this number algorithm way to describe what it does, okay, which is something that I have here, okay. So the number algorithm format, okay, and numbering algorithm formats that say, hey, what it does, what the type of it does. It say, hey, I'm going to take the value and I'm going to evaluate for unity expression. If the value is a record, then if it's unresolvable reference, okay, is true, return undefined. Set the value get, all right. If the value is undefined, return is undefined. If the value is null, return an object. That's interesting. If the value is a string, return a string. Is a symbol, is a boolean, is a number is a big int. And then assert the value as an object, and note that this step is replacing section B3. If a val has a call internal slot, return a function. Okay, so if this particular value has now a inner property, call return function, or otherwise return the object. Okay? And this is interesting. If a value is null, return an object. Well, exactly. If a value is null, it's going to return is an object. Exactly. If a value is null, return an object. So if you say, hey, type of null is equal to object, right? Why is that? Doesn't matter, honestly. There's no need to break your mind about this. It is just part of the specifications. And remember that undefined is the absence of declaration. Okay, you haven't declared this, and null is the absence of values. All right, you can think of this as a parking slot. Okay, so a parking slot is undefined when there is no any indication that it's a parking lot. Right, but if it has indications, but there is nothing there, there is no car. Well, you know, right? It is null. That's a good analogy here. That's a very good analogy here. Okay, now, a fix was proposed automatically via opt-in, but it was rejected. It will have result in type null equal to null, but it will break the entire web. So you don't want to do that. And that was interesting. There was actually a proposal in 2016. And they say, no, you know what? No. No. All right, so good, right? So we look now at the type operators.
Then we've reduced the whole surface area of confusion of what could possibly come back from this. We can predict its outcome much better. That'll be important later on. So type of is returning strings that represent, hey, here's some clue as to what you can expect to be able to do with values of this particular kind, of this particular type. Ergonomically, that's what we can then rely upon in our code. We have something that is going to behave as a number. We have something that is going to behave as a string. You'll notice we don't have all the values. Like we don't have a type of with an array to give us the word array. It's just going to give us back object because remember, arrays are subtypes of objects. So we're going to need further distinguishing if we need to get into those subtypes. But at the top level, we can distinguish roughly based on all of these. Now, I mentioned the null being on that list as special. You'll notice that when we say type of v equals null, when we say v equals null and type of v.
Exactly, the type of doesn't exist, it returns undefined. If the v is null,
we get back mode object. Now, this is a historical fact of JavaScript.
You got it, exactly. Something to know about this. Okay. You weren't there when this language was invented, so your opinion is like good to know, bro. You know. The type of null returning an object is the type of null returning an object. It is there for historical reasons. Okay, so don't break your bar on.
As a matter of fact, in the current spec that exists at this moment, it still has a statement that was there from like ES1, which essentially indicated to developers that if you wanted to unset a regular value, like a number, you would use undefined, but if you wanted to unset an object reference, you would use null. And I think that's part of the historical reason for why type of null returns object. But the real truth of the matter, I was tweeting about this years back, and the real truth of the matter is that it's just a bug. It ought to have returned, quote, null, to tell us that this is a value of the type null. Unfortunately, it returns, quote, object, so you have to be a little bit more careful. You have to make sure when you're doing a type of check and it returns object, make sure that it's not accidentally the null, because then you're not going to get an object, but a null value. And then we see function.
Exactly. Then we see function.
And you remember, function is not a official type at the top level in the most official sense, but it has its own return value here. The type of operator returns this function. So
Exactly.
it's useful that it returns to us function, but arrays it doesn't. Arrays just returns object. A lot of these are just, again, historical things about JavaScript. We can't fix them because if we fix them, we break a bunch of code.
Exactly.
So rather than whine or complain about them, we should just learn them and work around them. Okay? It's regrettable that you can't just say type of, but there are other helpers in the language. In particular, with respect to array, there's array.isArray.
Mm-hmm. So, unlike arrays, so arrays, unlike functions, again, for historical reasons, it returns a number, and that's interesting because let me understand this.
We get back quote object. Now this is a historical fact of JavaScript. As a matter of fact, in the current spec that exists at this moment, it still has a statement that was there from like ES1, which essentially indicated to developers that if you wanted to unset a regular value like a number, you would use undefined, but if you wanted to unset an object reference, you would use null. And I think that's
in the case of type of. If you want to unset that. Okay. The reason is that if you want to unset a value in ES1, okay, if you want to unset a value, tú quieres descolocar un valor en una variable, you use undefined, okay.
to unset a regular value like a number, you would use
Exactly. Like if you want to unset a primitive value in ES1, you use undefined, which makes a lot of sense. It's like, hey, I want now to reserve a space in memory here, or whatever value you have here. In the example of the parking lot, whatever car that is, gone.
Undefined, but if you wanted to unset an object reference, you would use null. And I think that's part of the historical reason for why type of null returns object. It's undefined, but if you wanted to unset an object reference, you would use null. And I think.
But if you want to unset an object reference, it. But if you want to return an object reference, you will use.
I think that's part of.
But if you want to unset an object reference, you will use null. Interesting. So if you want to unset a primitive value, all right, you use now undefined. But if you want to unset an object reference, all right, then you use now null. And this is one of the historical reasons why now when you use a type of, according to Kyle Simpson, when you use now a type of to check that variable or that identifier is null, that's what it returns now an object. It say now you are unsetting this value, you are now unsetting this object reference, and therefore this is the object, right? If you want to now unset a primitive value, then you do that with undefined.
The historical reason for why type of null returns object. But the real truth of the matter, I was tweeting about this years back, and the real truth of the matter is that it's just a bug. It ought to have returned, quote, null, to tell us that this is a value of the type null.
So the real
Unfortunately, it returns, quote, objects. You have to be a little bit more careful. You have to make sure when you're doing a type of check and it returns object, make sure that it's not accidentally the null, because then you're not going to get an object, but a null value. And then we see function here. Remember, function is not a official type at the top level in the most official sense, but it has its own return value here. The type of operator returns this function. So it's useful that it returns to a function, but arrays it doesn't. Arrays just returns object. A lot of these are just, again, historical things about JavaScript. We can't fix them because if we fix them, we break a bunch of code. So rather than whine or complain about them, we should just learn them and work around them. Okay?
Exactly. And here, this is interesting because this is part of the inheriting stuff that we have with type of. And now that we have instance of. And this is quite important to understand the difference between type of and instance of. Because with type of, all right, we say, all right, I want to now check the primitive value or the object's reference of this. And there's a finite set of constants that allow you to do that, right? So that's one. However, what happens when you want to check the value of different objects, all right? Object shapes or objects. So for example, like an array or a function or a map or a set, you know? So that's when we have now the or any user-defined classes that you, for example, you say, hey, I need this class called user, all right? And I want to check if when I create this class and assign that, so when I create this class, the AKA I reserving a space in memory and then assign to an identifier, which is the name of the variable, when I do that, all right, then how can I know that this is this particular class? How can I know that this is a reference or an instance of a class? And what it does, the instance of, is to check now the prototype change. And I want to, before going into there, look at that. Let me see if the instance of, this is instance of, right? Because it says to see if the prototype property of a constructor appears anywhere in the prototype change. If the constructor or this function constructor actually appear in the prototype change, then all right, now this is an instance, which is interesting how it defines that. How do you get the return value is a Boolean value. Behaviors can be customized with symbol has instance. Exactly. Here you create a function constructor, all right, with the new keyword. What it does is to say, hey, I'm going to now create this object for you, all right? I'm going to make the value of this keyword to be now scope to this function, all right? And then I will automatically create now a link to the prototype. So in other words, no, what it does is this. This is hard part. Well, I don't have that. I believe it. Really? This is the hard part. Exactly. Come on. The object-oriented programming. When you take a look now at the instance of the object creation, but with the new here. Because here you can now is create, this is how you can do with that, right? You can create now, this is older way, but with the new keyword, all right? With the new keyword, because here we're using is a new keyword, okay? With the new keyword, we say, hey, I'm going to create now an object and attach, because it's this one, okay? I'm going to create now an object that I will create now an object where the value of this, it is a scope to this function, all right? And anytime you want to add now a functionality to this, you're gonna do that through the prototype property, which is a property that all functions, constructors, owns, right? Exactly. So that's interesting, because now exactly, all of these are under the prototype. So because now what it's gonna do is to say, hey, let me check if this value, let me check if this variable that holds is this value. I'm gonna check if that has now in the prototype change a constructor which instance has which function constructor is of this shape. And that's interesting. Because you define the constructor, and here you say, hey, I'm gonna create now a new C. It says that, all right. O true because object of get prototype. O is an instance of C prototype. So what you're doing is to say O is an instance of C. It's a yes, because under the prototype object of O, it has a reference to C. And under the function object, because all functions owns now this is a two-part of the function anatomy. You have now the object part, where you can add property to it, and the functionality, which is under the prototype property. All right. And then you say, oh, it's instance of the. It's a false because it's nowhere on the prototype change. Oh, instance is true because it is an instance of the object. C prototype is an instance of object that is true, and reassigning the constructor property, you should rarely do this in practice. Okay. And when you do this, it is true, and false, it is like that. Okay, so yeah, let's move on. Right, let's move on.
Okay. It's regrettable that you can't just say type of, but there are other helpers in the language. In particular, with respect to array, there's array.isArray, and it'll tell you for sure or not whether you have an array. So that's how we distinguish these primitive values with their types. We can use utilities like type of, and when we need a little bit more specifics, a little bit more nuance, we can use utilities like array.isArray. They'll tell us something about the nature of the value, which tells us what we can expect. Remember big ints? They're a primitive type, so when you assign a big int, using a literal, for example, like line 2, 42n, it's not just the number 42, but it's 42 within this space where it can grow essentially infinitely large, up to the memory space on the system, of course. It can essentially have an integer that grows infinitely large. That's a separate partition. It's not an IEEE number like all the other numbers in JavaScript. And you have to be very careful because big ints and regular numbers, they don't really mix and match that well. They're totally separate things, if you will. And so it's going to be really useful for us if we have a thing that looks like a number to determine, is it a number or is it a big int? Which is why type of, at least at the moment, is slated to return us the string big int. A quick note on undefined versus undeclared. This is often confused. And it's confused because developers, quite naturally.
Exactly, kind of emptiness. This is kind of emptiness. The difference between undefined versus undeclared.
Really, think of these words as sort of synonyms. They seem like they mean kind of almost the same thing. And in English, that's probably true. But in programming, it's entirely not true. In programming, and especially in JavaScript, these are two entirely different concepts. So on the previous slide, when I said type of v, and I got back quote undefined, v, or whatever that variable is, didn't even exist. So how is it that I can get back quote undefined when something doesn't even exist? Well, that's another historical work, JavaScript trying to pretend as if the absence of a declaration isn't that big a deal. It's not that big of a problem. You can work around it. In retrospect, they never should have done that. They should have just returned the string undeclared. Undeclared means it's never been created in any scope that we have access to. And undefined means there's definitely a variable and...
Except that undefined is a different... Undeclared, okay. Undeclared and undefined. Undeclared is that there is no variable there.
Done that. They should have just returned the string undeclared. Undeclared means it's never been created in any scope.
Exactly. So undeclared means it's never been created. And undefined was created with no value assigned, with no type, with no value type assigned to.
Scope that we have access to. And undefined means there's definitely a variable, and at the moment it has no value. Very different things.
Completely. So undeclared is something that is means it has never been created. All right. Hey, you've never been created. It's undeclared. Okay. And the other is undefined. Is that hey, you already created, but has no value, with no value type assigned to.
The type of operator is the only operator in existence that is able to reference a thing that doesn't exist and not throw an error. Now, undefined and undeclared, we can fairly straightforwardly sift those out. But there's another concept of emptiness in the language that was introduced.
Uninitialized. However, there is another concept in the language that was introduced, and it is uninitialized, aka the temporal death term. This uninitialized is a concept from EX6 where you can define, when you can declare a variable you can declare a variable
Introduced with essentially ES6. And the best way to describe this is uninitialized. Another way of referring to this particular condition that a variable can be in is called the TDZ, the temporal dead zone. We're going to get much more into this in our next unit of discussion when we talk about scopes. We're going to talk about where this thing comes from. But essentially the idea is that certain variables, like block scope ones, don't get initialized. They never, and we talk about scopes, we're going to talk about where this thing comes from. But essentially the idea is that certain variables, like block scope ones, don't get initialized. They never initially get set to undefined. When something is in an uninitialized state, it is off limits. You're not allowed to touch it in any way, shape, or form, or you'll get an error. And the error you get is the TDZ error. So it's yet another concept that we have of like this emptiness. We can have a variable that's never been initialized. We can have a variable that's been initialized and is undefined. Or we can have a variable that was never even created and then it's undeclared.
Okay, the uninitialized concept from ES6 is when you cannot
don't get initialized. They never initially get set to undefined.
They never get initialized with undefined. Okay, the uninitialized is a concept from EXIS. It's a concept from EXIS where block scope variables let and const. Okay. Never get initialized with undefined. Holy moly. Never get initialized with undefined. Okay, okay. So claw here. So let and const are the only block scope variables, right? In JavaScript. Within the block scope. Interesting. Holy moly.
When something is in an uninitialized state, it is off limits. You're not allowed to touch it in any way, shape, or form, or you'll get an error.
When something is uninitialized, you are not able to touch it. It is off limits in any way, form, in any way, shape, or form, in any way, or form, you will get an error. You will get an error.
And the error you get is the TDZ error. So it's yet another concept that we have of like this emptiness. We can have a variable that's never been initialized. We can have a variable that's been initialized and is undefined. Or we can have a variable that was never even created and then it's undeclared. 3 different concepts that we need to wrap our brains around.
So if we want to make...
Within those primitive types, there are special...
So for example, we say something like this. Say, I'm going to define as a function to test that is, we call TDC. And then you define now inside of the block scope, all right? And by block scope is to say, hey, is this, right? And block scope, right, is whether it's on an iteration. And for iteration we have for, do while, or conditions. So if true, you then say, hey, console log dot, let's say TDC variable. All right. And if you do something like this, you define that this let TDC variable, all right, it's gonna define with nothing right now. And once you want to run this, you say TDC to JavaScript, you want to evaluate that and say is this, right? Uncut reference error, cannot have access to the TDC variable before initialization. Okay, it's actually telling you that. So variables here, so scope, okay, scope variables are not hosted in function scope. For example, you do something like this, you get an undefined. But if you define that later on, like this, all right, you're gonna get an error of that. And the other is that this is interesting because it also works for cons. Missing initializer in cons. You need to initialize is cons. Okay. So block scope variables like let and cons, they are not hoisted. Okay. And that's when you can get these particular errors here of the TD.
Special values that we should pay attention to. And there are a number of them, but I want to focus our attention on two specific special values. These are ones that crop up much more often than we would like, or at least some of them, at least one of them crops up more often than we would like. And awareness of both of them is going to help us avoid bugs, and in some cases even get more power out of our JavaScript language. So let's look at the first one. It's referred to as NaN, which is supposedly an acronym for not a number. Historically, that's where it comes from. NaN comes to us, at least in JavaScript, it comes by way of the IEEE 754 spec, the number spec. Essentially, NaN doesn't mean not a number. Essentially, it means this special.
Okay, the IEEE 754 spec is a set of technical standard for how numbers are represented. Holy fuck, that's interesting. It's a standard for how numbers are represented. The IEES, holy moly, that's interesting. This comes from the IEEE 754 spec. That's holy moly. Which is a set of techniques technical standard for how numbers are represented. An interesting topic, bro. An interesting topic. So I think this is the electrical engineering, right? What does it stand for? The Institute of Electrical and Electronic Engineering. Here we go. Institute of Electrical and Electronic Engineering. Okay, it's a bunch of people in the electric and electronic field that say, hey, you know what? We need to have a representation. We need to have a way of how we can map this stuff and a standard.
What we call sentinel value that indicates an invalid number. That's a much better mental model for it than referring to it as not a number. We ought to refer to it as and call sentinel value that indicates an invalid number. That's a much better.
Okay. What it does. Exactly what it does is to say that this is an invalid representation of a number. Makes a lot of sense.
A mental model for it, then referring to it as not a number, we ought to refer to it as an invalid number. So let's dig into that. How do we arrive at something like a NaN? Well, number one, you can take things that are representations of numbers in string form in this case. Like, for example, my age at the moment is 38, and I can represent that either as quote 38, or in this case on line 1, I can represent it in octal. The octal representation being 46. I don't like that one because that makes me sound a lot older, so I don't want to use that. But I can represent it in string form, and then I have a number, like the number 38. Or I can do quote 39 to reference my next age. I don't own cats anymore, so when I say my cat's age and I use something like not applicable, there's no number to use to refer to that. And let me be very specific and clear with you. The number 0 is not the way you indicate the absence of valid numeric value.
Exactly.
Talk to any mathematician, the number 0 is absolutely an important number. It is a number that has substance to it. It's not appropriate in any way, shape, or form to think of 0 as being the placeholder for absence of numeric value.
I
Doesn't
guess
make sense
represents-
mathematically, and it doesn't make sense programmatically. So, what number should we use? Well, that's what IEEE did when they defined this special bit pattern that represents this is the number that we indicate it's not a valid number. I can't do anything with n/a. There's essentially no number system where n/a is a valid representation of a number. I should have invented one. Okay. So we get NaN back.
So it's
We get
is
the
a-
invalid number back.
is
And by the way,
it's not
when
a
you do
number,
things with an
it's a
invalid number,
invalid
even things that seem
representation
crazy
of a
like
number.
subtracting strings, you're going to get
Interesting.
invalid number back.
Interesting.
Line 4, my age minus and then a string, like my son's age, doesn't actually make any sense. Not programmatically anyway. But JavaScript has a way of thinking about this that we often gloss over. In particular, JavaScript thinks about this as the minus operator needs numbers. It's only defined for numbers. When you give it something that is not a number, then it says, I need to turn it into a number. That's what we'll talk about when we get into coercion
Okay, exactly.
in a little bit. So it turns the, quote, my son's age, which, by the way, he's 8. My son's age, it turns his age, that string, into the NaN value. So when I say my age minus, I'm actually saying my age minus NaN, and NaN with any other mathematical operation is always NaN, because it's invalid. So NaN sort of propagates all the way out. There's nothing that you can ever do that includes a NaN and results in anything other than a NaN, mathematically anyway, okay? And by the way, you'll notice that even though my cat's age is NaN, it is not equal to itself, or at least according to the triple equals operator, it's not equal to itself. Many people like to believe that the triple equals operator tells you the truth, but I have news for you, the triple equals operator lies. It tells you that those two things are not equal. And the reason it does that is not because Brett
Is the my cat age?
was crazy that day. It does that because IEEE said NaNs are not equal to each other.
Names are not equal to each other. Okay. So names are not equal to each other. Okay. So in the my cat age triple equal my cat age, in the spec it is false because non-represent or because invalid representation of a numbers are not the same.
As a matter of fact, NaN is the only value in existence, at least in JavaScript, it's the only value that does not have what we call the identity property, meaning it is not equal to itself. It's the only value where that is true.
Undefined? Undefined is the same.
Undefined is absolutely equal to itself.
Undefined is absolutely equal to itself, exactly.
NaN is the only value that is not equal to itself. So
Shit. So NaN is the only value that is not equal to himself. Oh my god. It's because it's tripping, bro. To itself. It's because here this is when you're starting to try to be from the philosophical aspect of creating a language and define specs and rules to follow to the practicality of this.
So we need some way to determine, because triple equals lies to us, we need some way to determine if the value is in fact NaN. And JavaScript shipped originally with a utility called isNaN, which when we pass a thing like a number to it, we correctly get false. And when we pass a thing that actually legitimately is NaN, we get true. Seems great until we look at line 10, when we pass in something that is definitely not
a number.
The string my son's age. But let me ask you the question. It's not a number, right? We agree with that, but is it the NaN value?
Is not a numeric representation of this number? Or is a numeric representation of this number? It throw you true? What the fuck?
Most definitely not. So why do we still get true? The historical reason for getting true is because, for some reason, the isNaN utility coerces values to numbers before it checks for them to be NaN. So it's going to coerce the string my son's age to a number. And guess what number it's going to coerce it to? The NaN value. So of course it's going to return back true.
The NaN values, of course.
True.
Oh,
Now guess how I know that it does that? I read the spec. And the spec very clearly says, coerce it to a number.
Holy moly. That's mind-bending stuff, bro. Oh my god. So if I say, is not a representation, if not a representation, say, hey, hello world, it say, hey, I'm going to, it's a true, okay, this string is not a number, which is a not representation of this, is a non-numeric value. Yes, it's not a numeric value. It's not a numeric value because what it does is to coerce that into a string, and therefore coerce that into a number. And if it's not, that return is not a number, and it's not a number, it's a representation of this, which means it's true. Holy fuck. So if I use now the number instance, it's not a number. Hello world. No, it's not a number. Oh my god.
Sometime after that mistake happened in initial JavaScript, they decided that's a bad idea. So with ES6, we got a better utility, the number.isNaN utility. And that number.isNaN tells us definitely for sure it's the NaN value or it's not. In other words, it doesn't do any coercion for us. It tells us specifically it's the number. Segueing back to your question about what is NaN. Well, if I do a numeric operation and I get back a value, what type am I expecting back from every single numeric operation? I'm expecting a number, right? And
oh shit, in ES6 we use the number instance to truly verify if that is not a valid number.
And remember I said NaNs are part of the IEEE 754 spec, which is a numeric representation specification. So, perplexingly, the type of a NaN
here is a number.
Is number. It's just an invalid number. Okay?
Exactly.
Which is why it's not appropriate to think of it as not a number, because then you get into that weirdness, the wadding of type of not a number is number. That's because it's wrong to think of it as not a number. It's better to think of it as an invalid number. Mm-hmm. And of course, the type of an invalid number is definitely number. I have people suggest to me, no, they should have never done NaN. Never mind what IEEE 754 said. They never should have done NaN. We should have returned something else. Really? What should we return from a numeric operation that's going to be not of the type number? We could return back undefined, but that's not numeric. That's a terrible idea to give developers something that's a bait and switch. We could return back null, terrible idea. We could return back false, terrible idea. We could return back -1. This is old historical. When you do something like index of, and it can't find something in your string or array, because in the old C days you could only return numbers, and they weren't IEEE 754, so what was the only number they could come up with to represent in your string or array? Because in the old C days you could only return numbers, and they weren't IEEE 754, so what was the only number they could come up with to represent didn't find it, or invalid search? They chose -1. Which was fine for them like 4 years ago. I don't know why we adopted it in JavaScript, but we did. So we have some of our APIs that return back -1 when the more appropriate number that we had in the language to represent I didn't find it is NaN. If you're designing a system and you want to return, and somebody expects to get a number and you want to signal to them, there's no valid number for me to give, there is only one value that makes any sense at all. You should return the NaN. But more than any other complaint that I have on this list is when people try to refer to 0 as somehow a placeholder for NaN. And we'll come back to this in coercion in just a moment. So, NaN. It is a number, and it is the invalid number, and it is going to occur in your program.
So NaN, it is a number. Holy fuck. So NaN is a number. So NaN is a number that represent that is not a valid numeric representation. Holy fuck. Oh my god. Okay. Oh crap. That's interesting.
Program, not maybe, it will, and you should be testing for it appropriately. Otherwise you have bugs and you're not handling those bugs. Let's talk about another special value. This one seems rather strange because what on earth is a -0? If you ask a mathematician, they'll say that's made up, that doesn't exist, that's not a real thing. It definitely exists in programming.
Exactly. The other is -0. -0.
It definitely exists in IEEE 754. Just like NaN exists in IEEE 754, but a mathematician doesn't know what NaN means. Then it definitely also requires, IEEE 54 if you will, requires there to be a -0. So what does that mean? Well, it's essentially the 0 value, but with the sign bit on. So it is the negative representation of 0. Now, early days of JavaScript felt that JavaScript developers would never want a -0, and so they actually went to extreme lengths to try to pretend as if it didn't exist, which we're going to see a whole bunch of weirdness. For example, if I have a -0 assigned to trend rate, line 1 here, and I triple equals it with -0, I get true, sounds great. What happens when I stringify it? I'll use the toString method here, there's other ways, but if I stringify it, ooh, I get 0. That's not good, right? 0, where's my negative sign? The early incantation of JavaScript felt like JavaScript developers would think that it was a bug if you took a -0 and stringified it and got -0 in the string. They felt like that would look to the end user like a bug and JavaScript would get blamed. I think in retrospect, languages should do the correct thing, and it's on developers to do something that's reasonable to users. Languages should not step in and try to second guess their developers. And there's a bunch of the historical weirdness in JavaScript where they tried for various reasons to be more palatable. We got automatic semicolon insertion and a whole host of other things that were the language trying to outsmart the developer. And it turns out, don't outsmart the developer. Just let them do what they can with a sensible, reasonable, coherent set of tools. Okay, so the toString lies to us. And by the way, the triple equals also lies to us because it says that a -0 is equal to a 0. Oh, and also -0 is neither less than 0 or greater than 0. So the less than and the less than are equal, and the greater, I'm sorry, the less than and the greater than specifically, they lie. They all lie. So for a long time, we didn't really have a built-in way of determining if we had a -0. You could get -0s, but you couldn't determine that you had one until ES6 they added a utility called object.is. Object.is, I like to refer to this as like the quadruple equals. People like to joke about how double equals is, it allows all these different coercions and stuff. We'll get into coercive equality in a bit. They like to joke about double equals is changing and triple equals is exact, it's strict, except for a couple of lies. Well, if we don't want those lies, let's just add another equals on. So it's like the fourth equals here. It doesn't lie at all. If it's a -0, it gives you true, and otherwise it doesn't. And if it's a 0, it gives you true, otherwise, false, or otherwise it doesn't. So that's your only option, right, if you want to test for the 0. Actually, there's technically a mathematic operation, and that's a hint for later. There is a mathematic operation that you can use to determine a -0. But for the most part, the best way to do this is to use this built-in checker. And by the way, object.is can be used to check NaNs, although I would say number.isNaN is a more semantic tool for it, but you could also use object.is. So now you're asking yourself, okay, great, there's this weird nuanced thing that nobody cares about, right? Why? Who would even care about a negative zero? Well, I think there are legitimate purposes. I have actually used negative zeros in my programs before. Mathematically, it's very common for us to refer to two separate entities or two separate characteristics in the same numeric value. For example, the absolute value of the number represents, for example, how fast something might be moving, and the sign represents what direction it's moving. Say you've got a little car on a map, and this is actually what I had. I worked at a company where we built this mapping solution, and we had this little car that moved around the map, and I needed to know whether the car was moving this way or this way. What direction do I make it look when it stops? Well, I wanted to make it look in the same direction that it was before it stopped. How do I determine with one number what direction it was if at 0 we lose the sign? So negative 0 was actually useful there, and I've used those in games for very similar purposes. So our trend rate, as the going example goes, is that I could use the sign of this number. There's a utility called math.sign, which is supposedly going to tell us is this thing, does it have the sign bit or not? And that should have been able to tell us if we had a negative 0. Unfortunately, they went and did something super dumb, which was that they made math.sign return negative 0 and 0 instead of negative 1 and 1. So you can't really use math.sign to determine this. But if you wanted to make your own, here I'm making my own by basically fixing up the sign method, and I'm checking if on one of the two zeros, that's what happens on line 8, am I one of the two zeros, then I can, if I'm not one of the two zeros rather, then I can use the sign. If I'm one of the two zeros, I need to use object.is to figure out if I'm a negative 0. So that fixed up sign method, you'll notice down there in line 13, it returns a negative 1 when there's a negative 0. So yet another way that it might be useful for us to have a sign method that actually works, and here's a way that we can make a sign method that works in a useful way. There's some reason for the negative 0 thing in their return value, but I don't think it's very useful. Okay, so the trend example, as I said, the trend example, if I wanted to keep track of what direction something was moving, like if this was a stock or something like that, I want to keep track of, even if it's at 0, has it been falling or has it been going up? And I want to show whether it's been falling or rising in its stock price, for example. Well, here you notice that even if I track a negative 0, I can show that it's been falling at that point, as opposed to been rising when it gets at the 0 value. So negative zeros, even though they seem like they may be a little bit nuanced, they're a value that exists in the language, so you should know about them and know how to test for them. And now that you know that they exist, you might even be able to find uses for them.
For me, it's like it's still a hack for me, and I would rather define direction versus kind of hacking thing. For me, it's a hack. There's no math value. I mean, 0, 0, right? So it's a language that supports it.
Yeah. I understand that perspective, and that's entirely valid, but that sounds to me like when somebody says, I don't care about negative numbers at all, I just have numbers that have absolute values. I use, unsigned integers or something. Signed numbers are a thing, and they're a thing in math. Mm-hmm. So if they're a thing in math, then negative 0 is also a thing that can be useful. Okay,
to represent
so those special values, they're going to occur in our programs. And having an acute awareness of types and the values that can exist in our programs are going to help us not only avoid bugs, but also make better usage of our tool. Not only just be able to do something, but maybe do something more semantically. Maybe make something that makes our code more readable or more understandable. I would argue that it is much more consistent if I'm using positive or negative in my regular numbers to indicate direction, that I not have this separate variable to track 0's direction. It's very common for
negative zeros are used for directions, interests. So if you want to move from one place to another, right? And when you want to notify something to the user, is that, hey, is this also in trading apps? You say, hey, if this going up, going down, going up, going down, all right? So yeah, if you receive now a value, a negative value, you want to transform that into something. Okay. That's negative and positive 0, or the unsigned or the sign the sign value here or the sign value here, it is used in the industry to solve direction problems. All right. So for example,
Okay, it's still a hack
if going
for me,
up
and
or
I
down.
would rather define direction versus hacking thing. For me, it's a hack. It's not. There's no math value negative. I mean, 0, 0, right? So it's kind of it's a language that supports it.
Yeah. I understand that perspective, and that's entirely valid, but that sounds to me like when somebody says, I don't care about negative numbers
For
at all,
example,
I just have numbers that have absolute values. I use,
Moving.
unsigned integers or something. Signed numbers are a thing, and they're a thing in math. So if they're a thing in math, then
For
negative 0 is also a thing. that
moving
can
in
be used.
gains or
Okay. So those
up
special
and down.
values, they're going to occur in our programs.
Moving or up
And
and down.
having an acute
in
awareness of types
trading
and the
it.
values that can exist in our programs are going to help us not only avoid bugs, but also make better usage of our tool. Not only just be able to do something, but maybe do something more semantically. Maybe make something that makes our code more readable or more understandable. I would argue that it is much more consistent if I'm using positive or negative in my regular numbers to indicate direction, that I not have this separate variable to track zero's direction. It's much more consistent to me, and I think more communicative in code if I use the sign of the 0 to also indicate the direction. To get a better understanding of how primitive type values, and some of the special values work, we're going to jump into this exercise. In this exercise, we're going to make a polyfill. You're going to define a polyfill for that object.is utility that we just talked about. So in other words, no cheating. You can't go look at the existing implementation of it. You're going to write your own object.is. And in so doing, get some practice with the idea of dealing with these primitive values and their types and the corner cases and things like that. So the instructions here talk about defining an object.is. You've got to take 2 parameters. Remember, it takes 2 values as 2 separate parameters, and then it's supposed to return true only if they're exactly the same thing. Now, normally you would just use a triple equals for that, but the 2 major corner cases on triple equals where it lies are the NaN value and the negative 0 value. So you're going to essentially need to account for those first, and then if you're not in one of those conditions, then the triple equals would tell you if they are the same value. So the instructions here talk about handling the NaN and the negative 0, and you can use a built-in utility like number.isNaN, but there's also a way of checking for NaNs that isn't that. See if you can figure that out. You can also figure out negative zeros. So one last little note here is that we're defining a polyfill, and the polyfill pattern, as you can see here, is that you only define something if it's not already defined. So that's what a real polyfill would look like, is it would have that if statement wrapped around your definition of your custom function. The challenge here is that you're almost certainly working in a JavaScript environment that already has object.is, because that was ES6, so years back. So if you wrap it in an if statement, none of the code that you write is ever going to run, and you're just going to be testing yourself against the built-in object.is. So as a temporary hack, I would disable that if statement. You can disable it by literally saying something like or true, so that you're always defining one. You wouldn't leave that in, obviously, in your normal polyfill. But for the purposes of this exercise, since you're polyfilling something that already exists, make sure that you disable that if statement in some way, or you just comment out the if statement, okay? But just keep that in mind. You're going to be working in ex.js. You'll notice that in this file, I have a bunch of console log statements, and each one of them is asserting something about this test. And so the objective is that all of these console log statements all have to print true. That is that each one of these calls all return true, and each one of these calls all return false. So you know you have a passing test when you get all trues and no falses printed out. The way to run this code, you could open up this file and run it directly in Node from the command line. You could copy your code into a console and run it inside of a console, like in your Chrome developer tools. However you like to run your JavaScript, doesn't need any other surrounding information. But you're going to define your object.is polyfill here at the top, and then make sure that it passes all the tests.
All right, so let me make a quick pause here to take a sit and then do this. At least I'm going to dedicate the next 10 minutes to do that. Let's get into this. I'll be right back.